This is problem 9-6. It may seem a little bit intimidating at first, but it's actually not that bad. We can treat it as a regular RC circuit problem. So here we go. This is our circuit. Here's C and here's R, except this R is internal resistance. So from the graph in your prep book, you can see that it's an exponential decay graph. So it follows this general equation. V equals A times e to the negative kt. So you just pick 2 points from your graph and plug in this into this equation to find what A and K are. So these are the 2 points I used, 0, 10, and 141. So what I did here was a unit conversion, because the graph we had was in minute. The time was in minute, but we gotta convert it to second, which is the standard unit. Okay, so these are what I got. A equals 10 and K equals this. Okay, and then if you remember what K is 1 over tau, the time constant, which is 1 over RC. And we have C, which is 8 times 10 to the negative 6F. And then we plug in K, so we can get R. Okay, and then that's part A. Part B. So determine the approximate surface area of the plate. So you can find this equation on your equation sheet. And let's see what we have here. This K is not the same as this K. It's a dielectric constant, which is 5.6 in this case. And that's absolute naught. You can find that on your equation sheet as well. And you have C. This D is the thickness of the dielectric, which is 0.1 millimeters. And you gotta convert that into meters. So here we go. And so A, in terms of all these knowns, is like this. So we plug in values. I got 16. So part C deals with the resistivity of the dielectric. So we already know that R equals this. We find that in part A. So we can just use it. You can find this equation on your equation sheet as well. And this L here is the same as D. And this A is what we calculated in part B. Alright, just plug in values. Easy. So we got that. Don't forget a unit. So part D. So find the magnitude of the charge leaving the plates. Okay, so the change of charge equals Q final minus Q initial, and Q equals VC, right? So, which means that this equals VF minus VI times C. And then from your graph, we know that at when T equals 100, V equals 2. So read from graph. So we plug in 10 for VF and 2 for VI. Oh, actually, it's backward. But it's alright. Just whichever is bigger. And that minus that times 8 equals 64 microcoulombs.